Welcome to this video on smart prepayment. As we'll see, it's a little bit like Back to the Future. In order to understand smart prepayment, let's go back to some basics. Let's ask the question again, what is a meter? This is not as stupid a question as one might think, because it depends upon where one draws the boundaries. The primary function of a meter is to measure a commodity like electricity, water or gas, and so a meter contains components to measure the consumption of that commodity. However, unrestricted consumption of a commodity is a liability for the utility, as there's a risk that the consumer may not be able to pay for the commodity consumed. What is a prepayment meter? Utilities want a way to ensure that they're paid for the services delivered, and prepayment is the preferred method to do this. In the past, implementation choices were limited, and so to address the need, prepayment meters were introduced. These contained electronics to keep a running prepaid balance in the meter. So meters were also doing metrology as well as the account function. With prepayment meters, consumers purchase prepayment tokens, vouchers, which are then entered into the prepayment meter, typically via a keypad. They increase the meter's prepaid balance and enable further consumption of the commodity. In 1993, the SDS standard was introduced to provide a common model for prepayment and has since been widely adopted in developing economies. So looking where we are today, what actually has been the outcome of using prepayment meters? Well, they've greatly assisted utilities with revenue collection, but unfortunately, there's a but. Somewhat bizarrely, the very problem of non-payment, for which of course prepayment meters were introduced in the first place, is again a factor, largely due to the offline nature of prepayment meters. The consequence of the offline prepaid implementation has meant that the meters are essentially invisible to the utility after installation. Consequently, they are thus very prone to tampering, which is difficult and time-consuming to detect. These are regarded as non-technical losses. So for example, if a meter's prepaid token sales drop, does this imply fraud or merely a valid drop in consumption? This is of course the problem. So this is why the Back to the Future theme. Is it time for a rethink? Obviously, the measurement function of meters is still essential, but the approach of some meter manufacturers is to design and produce more complex and expensive prepayment meters. First, however, we should establish, given today's pervasive online connectivity, whether the original premise of incorporating the prepayment account function into the meter is still valid. So what is the alternative? Well, there's a very strong argument that meters should rather become simpler by returning to their core function, which is measurement, but they should have online capability to allow visibility and enhance functionality via the server-based participation. Online capability allows the prepayment function to be moved to a central server where it's easier to manage, not subject to tampering, and facilitates more comprehensive and appropriate tariff structures such as time of use. We refer to this as smart prepayment, but it's also known as virtual prepayment or thin prepayment in some quarters. There's nothing new in this concept, by the way. Prepaid mobile phones have always worked this way. So how does smart prepayment work? The consumer's account is held at a central server and not on the meter itself. An AMI smart meter takes and sends readings at regular intervals, which are rated immediately at the server and deducted from the consumer's prepaid account. If the prepaid account at the server runs out, let's say it gets to 0, the system will instruct the meter to disconnect the supply. When the consumer tops up the prepaid account through a payment at the server, the system will instruct the meter to reconnect the supply. So let's look at a real-life example of smart prepayment for electricity. An Elster AS230 smart meter with a smart grid intelligent modem sends readings to the SmartWorks service point manager, which validates those readings, and then they are rated by the service manager in real time. The cost of those readings is then deducted from the prepayment account held on the server. If the balance of that account is now less than or equal to 0, an instruction is sent to the meter via the smart grid intelligent modem to disconnect the supply. The consumer can top up the payment account from the payment gateway, so the balance will then become above zero and the supply will be reconnected also by the same channel. And here's a real-life practical example of Smart Prepayment Water. An Ulster conventional water meter with the Smart Grid Intelligent modem and limiting valve is used to send readings to the SmartWorks system, which again validates those readings, rates them in real time, and debits their cost from the account manager. However, in this case, if the balance is less than or equal to zero, instead of disconnecting the water completely, the limiting valve can be used to limit the supply of water. If the consumer tops up their account via the payment gateway, this will again use the valve to increase the supply. So there you have it, Smart Prepayment. Perhaps it is time to go back to the future. Thanks for watching.
We're sending you back to the future!